Alright guys, welcome back to the another video. In this video, I'm going to show you how to generate the image GIF using image collection. So this is the best way to visualize your image collection in a better way. So this is the basic one, and I'll also explain how to add the actual feature layer or the vector layer to your GIF, as well as the text. And the in the final step, I'll show you how to add the hillshade overlay to your gif, so that your final output will look like this. It's quite beautiful with the hillshade overlay, and this color represent the intensity of the reflectance value from nighttime. So yeah, this tutorial is quite fun, so I hope you will enjoy this. So let's get started. All right, so I'm here in the Google Earth Engine main site, and here the first thing first. First of all, I need to import my area of interest. Simply, this Nepal is my area of interest, and I'll write it as AOI. And then if I say map.add layer AOI AOI, and then maybe visualization parameter is false, and then this is AOI, and then if I run it, so I'll see the area of interest somewhere in Nepal, right? So yeah, this is my area of interest. Don't worry about this area of interest. So if you are unsure about any vector file, you can feel free to create the your AOI is any rectangle or any vector shape like this, and then simply write it as AOI. For now, I'm going to delete it because I already have AOI, right? And the next step is to, maybe I'll set it to false. So basically it won't load by default. And then also I'm going to set my map center to Nepal. And then if I run it, so by default, sorry, it should be AOI. And if I run it, so by default it will be zoom into the Nepal, and then if I click AOI, it will only load, otherwise it won't load. All right, so the now the another step is to find out the image collection whichever you want. For me, you might have already guessed it. So this is the nighttime light imagery. So I'm going to use this DMSP OLS imagery, which is available from 1992 to 2014, basically 2013. So since I'm going to use this imagery, so yeah, I'll don't worry, first I'll write the function and then describe it to you. So yeah, this is my function. So let me bring it down, and then here in the get night light imagery function, so I have year, and then year should be EE number year. So we are making sure that it will convert the year to the EE number, right? And then our start year will be the particular year Jan 1st, to the end year will be year plus 1. That means, for example, year is 2000, then it will be 2001 1 that means simply whole year, right? And then in the collection, as I said before, I'm using this night light imagery. Feel free to select any other imagery, for example sentinel or lancet as well. And then I'm adding start date and end date, which are right here, right? I'm simply filtering, and then I'm checking if the collection contain any imagery, simply by collection dot size. So it will provide me the number of imagery available inside this collection, right? And then simply I'm checking if condition. So if my imagery count is greater than 0, then I'm going to get the median and then select the average ABG BIS band, which is the reflected value of the night light imagery. And then I'm going to clip it to my area of interest, and then I am going to set the year as year. So for example, uh, inside this imagery, so I have this abc bis band, right? The minimum value is 0 and maximum is 63. That's why this value is the average of visible band digital number value with no further filtering, right? So that's why I'm selecting this reflectance value. And if the count is 0, that means if we did not find any imagery, then simply this function will return null, and otherwise it will return the actual imagery, right? So in order to test it, so first of all, maybe I think it's better to like create the collection of years, right? If I say print years, then you will see all the years, right? So simply basically it's from 1992 to 2014, right? It's the sequence. And then here in the imagery images, so I'm going to like map out my years with like this function, right? So basically the map function will take 1 year at a time and then pass it to night night lights function, and then it will simply process and then return the required output. For example, if I say images, basically it's the image collection or the list of image, sorry. Basically we get all the like image, all the years image. For example, in the 0, it might be from 1992, and then in the properties we can see that with the set year equal to year uh, command, so our year is set to 1992, right? So yeah, that's how we select all the imagery. But unfortunately in 2024 2014 we don't have any imagery, that's why it's returning null. That means our function is so far working properly. All right, maybe in another step I think we can like select the valid images. That means we are going to remove all the like null values from our imagery. It's best, always best idea to like check whether our imagery is null or not. Sorry, it should be images, and then run it. And maybe if I say valid image here, then we should get the list of 22 imagery. Basically it will remove the last null imagery from our list, right? So yeah, so now we have 22 imagery. And in the next step, maybe we'll like we'll set all the imagery to, we'll pass all the imagery to image collection. So basically we'll write valid images. So if I print image collection, then our output will be the image collection with like 22 images, right? So basically these all like feature represent all the images, right? So now if you want to see the particular images, for example the first one, and then maybe get the year, you will get 1992 in that case. Okay, right? So this is the way of getting year, or this is the way of like actually getting image, right? If you are still unsure how it looks like, you can also like visualize this imagery by adding the actual layer. Image collection dot first, and maybe in the visualization parameter I'll say nothing, and then this is first imagery. And if I run it, so it will automatically add the image, right? Yeah, that's great, but somehow we are not getting the actual like lights, right? This is because of the visualization parameter. So basically by default it's single band visualization, and then the value ranges from 0 to 225, right? But from this imagery source we got that value should be from 0 to 63, right? So maybe in this way maybe we can write 0 to 63, and then also we can make the palette of like colors. For example, maybe for the first one we can say it is black if the value is low, and then if the value is a little bit higher we can say red, and then if the value is slightly more higher then we say orange or yellow, and then if the value is really high around 63 we say it is like white. And then if I apply this function, then there we go, so we got this all like colorful maps. So it's all about like visualization, right? Of course this area is Kathmandu, our main urban city, so that's why we see very bright light in this area. And then basically in the western part, so the color is very light or even zero. This is because this area has very less population, and then maybe low light emission, right? All right, we are very close to generating the GIF. So in order to generate GIF, so I'm writing another variable called var GIF image collection. And then in this image collection, so I'm mapping out my image collection. Uh, Maybe with visualization parameter is maybe I can like simply import it. So it will be like my these params. Simply this visualization parameter contains the band, which band to visualize minimum maximum value, and then the palette, right? The selected color, right? So basically this image collection, GIF image collection, it's the like it's mapping the image collection function, image collection variable, and then it's passing each image at a time, and then it's visualizing our map based on this setting, and then it's clipping based on our AOI, right? And in order to generate the GIF, so basically we also need another variable called GIF create an animated GIF. And then this dimension, of course if you increase the dimension, then your GIF will be high resolution GIF means more dimensions, right? And then reason for me it should be AOI, right? Area of interest. And then frame per second, that means uh, it the image will be visualized only for 1 second, and then it will change to next, and then the format is GIF, right? All right. All right, so in order to generate the GIF, so basically we can rely on UI dot thumbnail function, and then we need to pass the our image collection, which is this one, right? Image collection with visualize parameter, otherwise your map will be like black, right? And then after that we also need to pass the GIF params is a second parameter. And then if I hit run, then okay, looks like there is some error. Oh, it's due to like geometry, because AOI is the feature collection, right? By default feature collection cannot be like passed in the region, so it should compute the geometry. And let's see our first GIF here. Okay, this is our first GIF, right? But sorry, I forgot to visualize here with my visualization parameter. So maybe I'll write params in map.add layer function. So if I run it, so it will also add the visualization parameter in this map, right? And here our GIF is ready right now. It's like changing color, right? That means it's the actual GIF. There are two problem in this map. The first one is we don't have text to represent which year we are visualizing, right? And the second problem is if you see clearly, if you try to zoom in more, then the boundary of the AOI is quite like attaching with the image boundary, right? Which is not good. That's why in that case, maybe in order to add some buffer, so maybe you can write the var bb box, that means the bounding box, and then we will compute the little bit of like buffer. So buffer of like maybe 30 kilometer. I tested it and then looks like 30 kilometer is the good distance. But if you run this and then run this code, you will you need to wait lot longer time and your Chrome might froze due to this computation, right? Since in this geometry we have lots of node, so in order to like reduce the computing power, we are going to simplify our geometry to only 1000 vertices and then do the buffer so that it will create the buffer, right? And then this is the bounding box, and then simply we are going to replace this region by bounding box. And if we do that, maybe I can also print out box and then run it. So yeah, now bounding box is computing, it generate the polygon with like 1300 vertices. And now my boundary between like actual image and then the actual site is quite far, so it looks a little bit nicer, right? All right, so we already generated the GIF with basic functionality, but in order to make it more beautiful, we need to like add the annotation text to our GIF and then overlay the vector layer and then overlay the hillshade so that we can make the beautiful GIF like this, right? So first thing first, first of all, I feel like the our GIF is missing the main important thing, which is annotation text. So in order to add the annotation text, so I copy and pasted some code from my previous repository. Here I'm going to explain it now. So for text, actually we required another library called user gena packages and text. So this is the way of like importing third party library. And then in the annotation, so we have this annotation parameter and we write where we want to annotate our text, right? Here it doesn't matter much these annotation things, but feel free to play with this annotation parameter. So here position is right, offset is 1%, margin is 1%, and property is label. And then the for the scale, actually if you write the exact number, so it will be like sometime it might not be visible and sometime it might be like really large. So that's why I computed dynamic scale. So basically it will compute the map scale, and then our text will be the multiply of 2. I'll show you how to like change it later. And in the position, actually, so in order to find the position, actually position of your annotation text, you can use the inspector button. And then for example, I want my annotation somewhere in my like, actually my image will generate like this, right? This box. And then maybe I need my text somewhere here, right? If I click here, then I'll get the point like actual latitude and longitude, right? So this is all hidden trial. So I find out for my map. So the longitude should be 80 and latitude should be 26.8. This is the best position to add the annotation, right? And in order to add the text, so simply we are going to add the annotation to each image. So that's why from timestamp we are getting the actual year. So this will return the simply the year, whether it's 1992, 1993, or so on, right? And then in the variable image, so we simply visualize it with like force RGB output equal to true. Even our image is single band image, you need to write this option, otherwise you cannot add the text. This is the drawback of this library, right? So even though this image is single band, so we are writing force RGB output to true, and then our minimum will be 0 and maximum will be 60 or 63, whatever number you want. Because in Nepal, I think the highest intensity is around 56, right? So yeah, it doesn't matter really, just for the visualization. And then we pass the palette, whatever palette we want. And then right now also like adding orange color in between red and yellow. Feel free to add more colors if you like. And then in the final step, we pass that label, like the timestamp, right? Timestamp we computed here. But the problem with this string is like some most of the time, if I did not slice it to 4, then it write it is like 1992.0, 1993.0 or something. I don't know, this might be some bug. That's why I slice it to 0 to 4. And then I add that and text to our image. And then I pass position and then the annotation text, and then return that and date, right? And then now I need to like loop this function, since this function work only on the image, not on the image collection. That's why I pass image collection, and then I map out all the like images to add the text. And then in order to see the actual change, I print like UI thumbnail, and then my like actual GIF image, and then the GIF param, right? And then this line will generate the link to download the actual video or GIF, right? So if I hit run, then it will take some time to run. Okay, it's generating thumbnail. Okay, now it's still generating. Okay, now we got this ear on like our left side, right? So yeah, this is very easy way to like add the text to give, basically with this package, right? So yeah, so complete task 1. So in next task, I'm going to add the Nepal boundary, so in white color, so that it looks much more beautiful. Otherwise sometimes it's hard to like figure out which is background and which is uh, our area of interest, right? So yeah, in order to do that, basically you need to like create the empty raster first. So I copy and paste the function. So basically we create the empty imagery here. And then for the Nepal outline, so basically we need to like paint this imagery with our feature collection is AOI, right? And then for the color and width, I am selecting 1, that means a little bit thinner width. And then I'm going to visualize with like palette equal to white. That means from white palette it will like take the first color, which is also white, and simply it will draw that into the canvas. So basically we are here converting our like actual feature, which is vector AOI, to the raster. And then we are now, this is our image collection with GIF, right? GIF image from before. So we are going to map out for each imagery, and then we simply blend that to the Nepal outline. Simply it means like merging two styles, right? And then if I hit run, then definitely we'll get that outline boundary. All right, so it's loading. Okay, there we go. So yeah, this is the outline boundary added by our this like blend function, right? So yeah, so the now final step in my this tutorial is to add the hillshade. So adding hillshade is also similar to like adding vector layer, but since it's already raster, we don't need to do anything. So we don't need to like convert our vector to raster. So basically for the hillshade, I'm using hillshade layer srtm gl1 layer. Simply if you search it, so this is the layer. So here the resolution is 30 meters, so I'm using this dame. uh, and sorry, it's not the dame, maybe it's the hillside. Oh, it's hillside or dame. I think it's dame, right? So I'm using NASA srtm 30-meter dame, and then I'm multiplying it to 100, so in order to like exaggerate the elevation to increase contrast in hillside. And then I'm clipping this to the actual my AOI boundary, because if I don't clip, so it will cover all the area, right? So after that, in the final visualization call, I'm calling previous previous giff function, and then mapping it to the image, and then I'm returning it with like hillshade dot blend. Simply I'm blending my image with visualization opacity of 0.6%. So basically if I run this, then it will add the hillshade style, it will blend the hillshade style to our gif imagery. So it's still computing. Okay, now there we go. So this is the hillside map, right? So if you want to download it, simply click this link. So this link is coming from like get video thumbnail thumb URL, right? So basically this is the image we want, and then you can say control s to save this imagery wherever you want, and then maybe you can write whatever name you want, gif, right? So yeah, and the other thing I would like to mention here is if you want the really high resolution gif, maybe you can change it to 1000 and then hit run, but definitely it will take lot more time to run than with 500. And sometime if you really increase this dimension more and more, the chrome might crash, or the uh, google earth engine might throw you an error. Yeah, so yeah, it's still generating the gif. And then this gif was with the 500 dimension. Of course you cannot see much different, but this gif is with 1000 dimensions, so that means it's much more like clear than this one. So yeah. Yeah, so basically you can follow this tutorial to visualize any kind of image collection. For example, if you want to visualize NDVI, or if you want to visualize some sort of like Sentinel or Lancet imagery, or even the change analysis, change detection analysis. So this is the perfect way. So I hope you enjoy this video. If you enjoy it, hit the like button and subscribe to my channel. Thank you for watching.